Welcome to the Spelling Bee Ninja podcast, where we empower students with the knowledge and skills to thrive in their academic journey. If you're looking for accessible, fun, and free educational content designed to enhance your understanding, you've come to the right place. Be sure to subscribe so you never miss an episode, and join our vibrant community of learners who are eager to dive into the fascinating world of learning together. Today, we're exploring the essential concepts of mean, median, and mode, key tools used to summarize data. Understanding how to summarize data accurately is essential in mathematics and statistics, and today, we're going to break down three fundamental concepts: mean, median, and mode. First, let's talk about the mean. Often referred to simply as the average, the mean is calculated by taking the sum of all values in a data set and dividing it by the total number of values in that set. To illustrate, if we have the numbers 4, 8, 6, 5, and 7, we would add them together, resulting in 30. We then divide this total by the number of values, which is 5, leading us to a mean of 6. This tells us that the mean provides a central point that represents the dataset. It's interesting to note that the word mean originates from the Old French word moyenne, which means middle. Thus, mathematically, it serves as an average value that many rely on to provide insight into a given set of data. And next, let's explore the median. The median is defined as the middle number in a sorted list of numbers. If you have a straightforward set with an odd quantity of data points, identifying the median is simple. The median is the center number. For an even set, however, you take the average of the two middle numbers. For example, in the sequence 3, 5, 7, 9, and 11, the median is the number 7. In contrast, if we look at the set 2, 4, 6, and 8, we've got an even number of values, so we find the average of the two middle numbers, 4 and 6, which gives us a median of 5. This characteristic makes the median incredibly useful, especially as it is less impacted by extreme values or outliers that may distort data, such as when analyzing home prices in real estate, where a few very expensive properties can deeply skew the average prices. And then, we have the mode, which is defined as the value that appears most frequently in a dataset. The mode can vary. A dataset may be unimodal, showing one mode, bimodal, revealing two modes, or even multimodal with several modes. Conversely, a dataset can also have no mode if all values occur with the same frequency. Consider the numbers 2, 3, 4, 4, 5, and 6. Here, the mode is 4 because it appears twice, while a sequence like 1 through 5 has no mode, as there are no repeating numbers. One fascinating aspect of the mode is its application to categorical data, where it can show the most popular option in a set. The term mode itself is derived from the French word for fashion or style, highlighting the idea of popularity. And now that we know the basics, let's talk about the range, which tells us how spread out numbers are in a dataset. The range is determined by subtracting the smallest value from the largest value. For instance, in a set with values 4, 7, 9, 12, and 15, the range is 15 minus 4, which gives us 11. Understanding the range alongside the mean, median, and mode provides a fuller picture of data distribution. A greater range indicates more variability among values, which allows for a better understanding of the diversity within the data. It is the simplest measure of variability, but it's essential to recognize that it can be significantly influenced by outliers, those extremely high or low values that stand out away from the rest. And speaking of outliers, they can dramatically affect the mean by pulling it toward their extreme value. In contrast, since the median relies only on the middle values, it remains more stable in the presence of outliers. The mode, too, is typically unaffected unless an outlier is a notable repeated value. This behavior makes the median particularly beneficial for datasets that contain outliers, such as income or housing data. It's often why the median is preferred in many statistical analyses. Fun fact, a recent film about the NBA used the median salary of players instead of the mean salary to avoid skewing the numbers with superstar salaries that are much higher. And when should one use mean, median, or mode? The mean is best used for roughly symmetric data without extreme outliers. It shines in situations with interval or ratio data. The median becomes necessary when outliers are present or when data is skewed, offering a more accurate representation of the central value. The mode comes into play when identifying the most common values, especially useful in fields like retail where tracking best-selling products is vital. Presenting all three measures provides the most complete view of data. Interestingly, Surveyors often use the median to report income statistics, as means can become misleading when few very high incomes push the average higher than what is typical. And next, let's look at frequency distributions, a tool that organizes data points by showing the frequency of each value or category in a dataset. Typically represented in tables or graphs, frequency distributions help visualize how often each value occurs, forming the foundation for calculating central tendencies and creating visual aids like histograms and bar charts. For example, if we had a frequency distribution of test scores, it would detail how many students received scores of 80, 85, and 90. It's fascinating to consider that Florence Nightingale used frequency distributions during the Crimean War to illuminate the causes of soldier deaths, dramatically shifting public health statistics toward easier analysis. And another important concept to grasp is the weighted mean. This average takes into account the significance of each value, where specific values are given more weight than others in the overall calculation. When calculating things like grades, different assessments can carry different weights. For instance, if exams are worth 40% of the final grade and homework accounts for 60, the weighted mean allows for accurate computation by multiplying each grade by its weight and then dividing by the sum of the weights. This method is crucial across disciplines such as economics and education to assess elements that carry varied importance. Just consider how the Consumer Price Index uses a weighted mean to evaluate various goods based on consumer spending habits. And lastly, it's essential to understand how mean, median, and mode operate in real life. From calculating average returns in finance to summarizing typical home prices in real estate, these measures are everywhere. Retailers utilize the mode to identify top-selling items, while pollsters often reflect household incomes or socioeconomic data through the median to provide clearer insights. The use of these statistics is truly omnipresent, informing businesses on customer behavior, guiding policymakers, and helping scientists analyze their research data. Did you know the median is frequently cited in housing reports? Using it can lead to more accurate representations than the mean, especially in markets swayed by a handful of expensive home sales. And in summary, measures of central tendency, mean, median, and mode serve as crucial tools in statistical data analysis. They give us a clearer picture of a dataset by highlighting the typical value, enabling us to make comparisons and informed decisions based on the data at hand. With our modern world overwhelmed by data, these concepts allow for a simpler, yet meaningful communication of complex information. And it's worth noting that the origins of averages can be traced back as far as the 9th century, where scholars calculated them to improve the accuracy of astronomical observations. Today, we dove deep into the mean, median, and mode, essential tools for summarizing data. We learned that the mean serves as an average, the median offers a stable middle point in a sorted list, and the mode highlights the most frequently occurring value. We explored how outliers impact these measures differently and discussed when to choose one over the others. We also covered concepts like range and frequency distributions, along with the weighted mean, all integral to analyzing data effectively. Each concept enables us to interpret data in more applicable ways across various fields, enhancing our understanding of information around us. Thank you for joining us on this episode of the Spelling Bee Ninja podcast. We hope you've gained a clearer understanding of mean, median, and mode, along with their significance in data analysis. Make sure to subscribe for more in-depth learning insights and keep expanding your knowledge. Remember, understanding data isn't just for school, it's a valuable tool in making sense of the world around you. Until next time, keep learning and stay curious.